friends, today we are gonna discuss some subjective questions of electronics measurement 2, which are our subject in diploma in electronics of 5th semester. These questions are 2017 and all questions are important for our upcoming examination. So let's move to the question. So the second number question is, discuss the problem associated with the measurement of resistance, inductance, capacitance at higher frequency. So the answer is, there are various effects which are predominantly at higher frequency. The first effect is high reactance due to stray series resistance and its variation with frequency. The another effect is low reactance due to stray shunt capacitance and variation of frequency. The another effect is increase of effective resistance with frequency of on account of skin effect. The last effect is variation of dielectric loss of capacitance with frequency. Okay, so let's move to the another question. Explain the circuit diagram of electronic voltmeter using a series connected diode. So the circuit diode voltmeter consists of PMMC meter, load resistor, vacuum tube diode. Okay, the vacuum tube diode connection in series with series resistance. This series resistance raises the strength of weak signal because the vacuum tube system becomes more sensitive than normal voltmeter. This is the figure of vacuum tube voltmeter, so remember it. The resistance of the series resistor is very high as compared to the of vacuum tube diode. Thus the resistance is neglected. The linear relationship obtained between voltage and current, the input supply, deflects the pointer of the PMMC meter, which indicates the magnitude of measured voltage. The third question is, what describe the meaning of oscillator? Describe the classification of oscillator. Okay, so what is an oscillator? The answer is, an oscillator provides a source of repetitive AC signal across its output terminal without needing any input. Expect a DC supply. The signal generated by the oscillator usually constant amplitude. Oscillator may be classified by the type of signal they produced. Sine wave oscillator produces sine wave output. Relaxation oscillator and a stable multivibrator produces square wave and rectangular pulses. Sweep oscillator produce sawtooth waves. Okay, so the third question is explain the different type of distortion caused by amplifiers. So the answer is, distortion in amplifier basically employs the variation in waveform received at output with respect to input. Okay, received at output with respect to input. The unwanted alteration generated during amplification is known as distortion. So the type of distortion in amplifier is linear distortion or non-linear. Okay, linear distortion, frequency distortion, phase distortion, and the non-linear distortion is amplitude distortion. Non-linear distortion. This type of distortion occurs in amplifier when the signal input is large and active device is driven into non-linear region of its characteristics. Amplitude distortion. This is a classified of non-linear distortion. This is due to attenuation in peak value of waveform and incorrect biasing and clipping. Okay, so the linear distortion is this type of distortion occurs when a small input, and non-linear distortion occur when the signal input is large, and linear distortion occur when the signal input is small and drive the device operates in linear region of its characteristics. Okay, the mainly occurs due to frequency dependence characteristics of the active devices. So frequency distortion in this level of amplification varies with respect to frequency. Phase distortion, it is also known as delay distortion. As the name indicates, whenever time delay occurs between input and output, it is said to be phase distorted signal. The fourth number question is describe a spectrum analyzer. So what is the spectrum analyzer? The instrument used for analyzing waves in frequency domain is called frequency spectrum analyzer because it displays the energy distribution of the signal on its CRT screen. A spectrum analyzer is defined as the study of energy distribution across the frequency spectrum of an electrical signal. The study gives information about bandwidth, effect of different types of modulation, and spurious signal information. The another question is define the term fidelity and noise figure. So the fidelity is defined as the remains ability to reproduce in its output the signal appears at input. Fidelity of receiver is determined by low and high frequency characteristics of the audio amplifier. In FM, fidelity is low and AM fidelity is high. Pre-emphasis and de-emphasis are used in receiver to improve fidelity. What is the noise figure? So the noise figure is an amplifier is defined as the ratio of signal to noise ratio at input and signal to noise ratio at output. This is the formula of noise figure. Figure of merit is defined as 1 upon noise figure. Signal to noise ratio at the output of an amplifier or receiver is always less than signal to ratio at input, hence noise figure of an amplifier or receiver is always greater than unity. The fifth number question is describe the process of high frequency measurement using resonance method. Okay. It is the most commonly method used for high frequency measurement. In this method, a series RLC circuit is used to obtain resonance condition. The EMF of the circuit is obtained by coupling the coil L with the output of an oscillator. So this is the figure of a RLC resonance circuit. It is connected electronic voltmeter, a capacitor in parallel with milliammeter resistor, and this is inductor, this is output oscillator output coil. So the resonance condition is obtained either by variation of frequency of oscillator or by variation of capacitance and the frequency keeping constant. Resonance condition indicated by millimeter and millivoltmeter when the reading of ammeter or voltmeter is maximum. This condition is called resonant condition of the circuit. Question number 5th or is what do you mean by quantization? So the quantization is the process of constraining an input from a continuous or otherwise large set of a value to a discrete set. Question number 6 is explain synchrose with its uses. Synchrose is a type of transducer which transforms the angular position of the shaft into an electrical signal. It is used as an error detector and as rotatory position sensor. The last question is what do you mean by primary and secondary standards? So the primary standards is a factual universal measurement while a secondary standard is a directly calibrated previously by the primary standard. Thank you.